In the earliest days of the Altair computer, the only mass storage options were paper tape or cassette. If you really want to know what it was like to use the computer in those early days, I think it's very important to spend a good deal of time using just paper tape or cassette for your storage without cheating. For example, take on a significant development in BASIC maybe, or assembler editor package, do an assembly language development. Something that over the span of a few days, you'll load and reload BASIC or the assembler a few times, and you'll have to save and load the files you're working on, your source files and object files a few times. And when you've done that, you've learned all sorts of things about the computer, about assembly and 8K BASIC. You'll also really understand what it was like to use the computer in those earliest days. And you will fully understand why introduction of the 5¼ inch floppy drive was such a game changer for this marketplace. It was just dramatically faster and more reliable, and it opened up the computer market from being hobbyist curiosity only to a useful tool for a much wider audience. And of course, that greatly expanded the market, and the microcomputer then took off. Now, ironically, the 5¼ inch floppy drive seemed extremely slow and unreliable within 5 to 10 years after this. And the hard disk, of course, took over. But then technology always marches on, but that's an entirely another topic. All right, so if you had an Altair back in its earliest days, most likely your operator console was one of these, Model 33 teletype, and you would probably use the paper tape that was on that for loading and saving programs. Unfortunately, getting one of these teletypes in good condition and then keeping it that way to run long enough to do several hours of punching and loading tapes is not easy. So this is probably not going to be a feasible alternative for most of us. Instead, that leaves the cassette route being a little more optimistic. And for the cassette, you're probably going to want to run the Altair Cassette Interface inside the computer. At this point in time, Altair had the best software, of course, partly in thanks to Bill Gates and company. So you'll need the Altair Cassette Interface, the 88 ACR, in your computer. Now, unfortunately, that cassette interface board is also very rare. And when it does pop up on eBay, it tends to go for collector prices instead of more reasonable prices. So that may not be a good option either. So in this video, I'm going to show you how to take more readily available hardware and create a 100% compatible drop-in replacement for the cassette interface. This is the Altair Cassette Interface, the 88 ACR. If you look closely, you'll see it's actually a two-board set. It consists of the board you see right now. That is a serial interface board. This is what the software actually talks to in order to communicate with with the cassette. And strapped to it with spacers and screws is this board on the back, which is the modem board. The modem board, of course, takes the serial digital data and converts it into a pair of tones to write to tape, and then converts tones from the tape back into digital data to go back to the UART on that serial board. So if we want to duplicate the functionality of this board set, what we need is a serial interface board that looks identical to this one from software's perspective. So that means the same port addresses for the status and data registers, the same position for the status flags to indicate new data, etc. And then we need a modem that can duplicate the modulation used by the board here so that any tapes we read and write will be interchangeable with tapes that were read or written with the ACR and vice versa. Now, as far as the serial board is concerned, you might say, let's just use the serial board you see here. Because yes, this was actually an existing product for MITS before the cassette interface was made. This is the 88 SIO. It's their first serial board. The problem is this board is also very rare and also tends to go for collector type prices. So I'm going to say that one's not an option. So instead, for the video today, I went with this board you see here, any second now. I went with this blue board called the IO4 board. It's made by Solid State Music. And you've seen this board in several of my other videos. It's a great chameleon board. It can look like most anything from those early days in terms of simple I/O boards. It's got 2 parallel ports on it and 2 serial ports on it. And again, it's very configurable. You've seen me use it like an Altair parallel board or an Altair serial board and a few other things. Now, this board isn't exactly flooding the used market either, but it is more readily available than the cassette interface, and it doesn't claim such a high price as those. Now, this is not the only board that could possibly be used for this. This is probably the easiest, but it's not the only one. And at the very end of the video, I address that for some other serial boards that might be able to fill the need of, fill the role of playing a cassette interface for us. In order to make this board look identical to the 88 SIO used in the cassette interface, first thing we need is two I/O ports at addresses 6 and 7 for the UART. I/O address 6 is going to be our status register, and I/O address 7 will be the data register. Now on this board, as we said, there's two serial ports, and they always occupy 4 consecutive addresses. So with this switch right here, I can set the address to 4. That gives this first UART addresses 4 and 5. It gives this one 6 and 7. So this second UART over here will be the one that actually takes the role of our cassette interface serial port. Now, in addition, we need it to be in the order that, the status register is first, followed by the data register. And there is a dip switch on here called PR, port reversal, and that allows you to have those in either order to, again, emulate most anything out there. So of course I have it in the order where status is first at 6, followed by data at 7. The next thing we need is we need the transmit ready flag on bit 7 of the status word, and we need the receive data flag on bit 0. And that's actually done with this header right here where you can see the wiring. So right here we're taking this transmit data available, and a little wire goes up there to bit 7. That ends up going to the processor, and the received data comes down here to bit 0. So that way we can match the position of the two flags that the software expects to see. None of the other flags in the UART are used. Things like parity error, overrun, framing error, none of those are used. So all we really need is these 2 bits. Now you may think it's kind of odd that I can adjust where the bit positions are here external to the UART. And the reason is because this is an older UART that did not have a status register inside at all. Instead, all of the signals that you expect to see in a status register, like data ready, transmit ready, parity error, etc., they're all just pins on the UART. And so on this board, the status register is external to the UART, and basically these pins are then just gated through a 74-367 buffer or a 368, we'll talk about that in a second, onto the bus. And so this allows us to put those bits in any order we want. And in fact, the 88 SIO over in the cassette interface uses this same UART. In fact, any board that's a possibility for working uses that same UART as well. And that is, again, addressed right at the very end of this video. All right, so we have the flags in the proper position, bit 7 and bit 0, but now we need to get the polarity right, because in the 88 SIO used with the cassette interface, transmit ready and receive data ready are negative logic, meaning they go to 0 when they're true. And with this board, you can just swap out this buffer chip right here. If you put in a non-inverting buffer like a 74-367, you get positive true. If you replace it with a 74-368, which is just an inverting version of the exact same thing, you get negative true. So of course I got a 74-368 in that spot to give us our negative true bits. All right, the next thing we need is 300 baud. That's done down here with this header. I have port A left at 9600, and this wire up here is giving this one 300 baud. And at this point, we have everything on this board done to make it look identical to the cassette interface serial interface board. Now, the I/O from this board goes through this 14-pin socket up here. There's current loop drivers and RS-232 drivers. I've chosen to use the RS-232 drivers. Now I could of course go from this connector straight to the modem, but what I've decided to do is go from here to the rear connector to a DB25, and we'll show you this in a minute, which would be the standard way you would use this anyway. And then the modem, I'm also going to have it terminate in a DB25 in the back of the computer. So whenever I want to hook this serial board to the modem, it'll just be a short DB25 cable external. And that way, by standardizing that interface, I can swap in different modem solutions. I can swap in different serial board solutions because I've standardized that interface. For a modem, I'm going to use the cassette interface board from the Altair 8800 clone computer. As of the making of this video in late 2003, that board is still available for purchase. If you look in the bottom right corner of this rear panel, you can see the 2 audio connectors for the cassette interface, tape play in and tape play out. Let's take a look at that and see how that was done with this board from the Altair clone. As you can see, those connectors are actually right on a circuit board, and that circuit board is basically mounted by those connectors onto the rear panel. Now, of course, sorry about all the bouncing. This was designed for the clone, not necessarily for using with an S100 computer. And in the clone, serial data to and from the host processor, the main board, came through this connector at TTL levels. And it would then be converted to audio to go out for recording, or audio coming in would be converted back to TTL serial data on that connector. Now this board also has an RS-232 converter chip right here. That's one of the Maxim parts. And it puts that data onto this header right here, which then allows easy use of one of these, just a IDC cable to DB25, and that can of course mount in the back and hook to that. So now we have an RS-232 port in the back of this computer. Now in the clone, that was used to get an extra serial port. So if data was coming in here and you were using the cassette, it would be routed to the audio ports. If, however, you were not using the cassette, it would be routed to and from the RS-232 level port on the back. So that way you got extra use out of this board. Now in this application, what we'd really like is to use that RS-232 port to have data that we route to and from the audio connectors going to the cassette. Because any serial board we find is going to support RS-232. So what I've done is updated the firmware in this little PIC processor on here to allow RS-232 data to essentially be the host data and get routed to and from the cassette. You can still install a jumper on this board up on this upper header, and then this will behave like it did in the clone in case you wanted to use TTL level data. For example, if you're hooking up to an Arduino or Pi Zero or something like that. All right, so now we have everything we need. We have a serial interface board that looks identical to the SIO board that's part of the cassette interface from Altair. It communicates at RS-232 levels. That's this cable right here, by the way. I'll show you all this in a minute. And then we're going to put another RS-232 port here and just loop the two in the back. And then we've essentially hooked our serial board to this modem. So let me go ahead and take a step back, and we'll take a look at all the equipment in this computer to make this work. And then we'll go ahead and demonstrate it by loading AK Basic. Let's take a look at the hardware we're going to run this demo on today. We're running in something I dubbed an Altair 8800C computer. It's kind of a combo of modern and vintage hardware. You can see we've got modern power supplies in the back. The cabinet itself is from an Altair 8800 clone computer. This CPU is an exact duplicate of the original Altair CPU. Same board artwork, same parts. The only difference is the actual circuit board is modern so that hobbyists today can continue making that board. All right, behind that is a front panel interface board that allows me to use a ribbon cable to hook to the front panel as opposed to those 60 or 70 white wires on the original Altair. Other than that, it works pretty much the same as the original. Behind that is our RAM. This is an original Altair 16K RAM board. And that works good for loading AK Basic because you still have 8 to 9K available for your program. All right, behind that is our blue board, the IO4 board that we made look like the 88 SIO that's part of the cassette interface. If you recall, the 14-pin header is where data comes out for the port B that we're using. I have the 3 wires of transmit, receive, and ground, and I also have a 4th wire that has 5 volts on it. And that 5 volts we'll use to power the cassette interface board. We'll look at that in just one second. And then finally behind this is I have a drop-in equivalent of Altair's 88.2 SIO serial board. This board was more widely used than the old SIO, but unfortunately it's not compatible for doing cassette. Well, there's a trick we can play with that, and we're going to look at that in the next video. So be sure to watch that one about doing cassette with a 2 SIO. Anyway, so this board is made by Martin Eberhard. It duplicates everything the original SIO can do, plus some. It actually has some ROM on it. And we're going to take advantage of the ROM and use the Altair's multi-boot loader, which I have in ROM on here. That saves us from having to toggle in a bootloader. So I'm using just one port of that. That goes to the rear panel and connects over to the terminal that we'll be using for this video. All right, so down here in the back, you can see the cassette cable goes to this RS-232 port. Right next to it, I have the RS-232 port for our cassette interface board. On pin 18 down here is our plus 5 volts, which isn't used for anything in RS-232. And I have that routed down into this board, so this way we have power for the board without having to run a separate connector to it. When it was in a clone, it would normally get power through that header. All right, so in the back, you can see our console connection. You can see the 2 ports are hooked to each other, so this is coming out of the serial board. This is going in and out of the cassette board. These are both wired as DCE, so I had to do this little twist here to swap 2 and 3. And there was a reason I wanted them both wired as DCE, so I just left it that way and swapped it on the outside. And then down here you can see we have tape play, the audio plate cable connected so that we can get the output from the cassette for loading AK Basic. And then we'll demo saving a program, and we'll move that cord over here to the tape play out jack. All right, so that does it for the hardware. Let's go ahead and get this thing fired up, and we will boot 8K Basic using our cassette interface, using all original Altair software and boot proms to make it happen. All right, so this demo should look pretty familiar to you, especially if you've watched other of my videos, because we're just going to load 8K Basic from cassette, which is going to be exactly the same as you've seen in my videos, because what we have done is create a drop-in equivalent of the Altair cassette. So we're going to turn it on, give it a hard reset, and rather than switch in a bootstrap loader by hand, we're going to use the multi-boot loader ROM from MITS. Again, we have it on the 2SIO JP card in there you saw. So the multi-boot loader is at FE00. We'll examine that. That sets the program counter to FE, and this is the content of the first instruction in that. And now we need to tell the multi-boot loader what type of device to load through. So these lower 4 switches determine the device we're loading from. A 30011 says we're loading from cassette. The upper 4 are then used to tell BASIC, when it gets up and running, what to use as a console port. 000 or 0001 tell it it's a 2SIO board. All right, so we're all ready to run. So I'm going to come over here to the cassette, release it to play, and hit run. And now we just sit back and wait for it to load. AK Basic takes about 4.5 minutes to load, so we'll do a video cut and come back when it's about ready to complete. All right, this should be getting pretty close to finishing up. When it does, we'll see the LED pattern on the front panel change as the addresses shift to where 8K Basic runs as opposed to the multi-boot loader. And then over on the console terminal, we should see the memory size pop up. All right, here we go. Yeah, so we're running Basic. You can see the LED pattern change. Let me stop the tape. And we can have a memory size prompt over here on the screen. All right. Go ahead and just click return. That uses all the memory. Default width, we'll say yes for that. And now we're up and running 8K Basic. Oops. All right, so you've got 8K Basic has cassette support in it. They have the cload and csave commands to load and save programs. So I'm going to use it to load a small primes program I have out here on tape. Let me fast forward this to it. Cload primes. All right, the tape's in the right spot. So I'll push play on the tape and hit return here. Now the file name, in actuality, the only thing csave and cload pays attention to is the first letter, so I could have just typed P because that's actually what I was saved with. That's all it takes. This is fairly short, so it shouldn't take long. Okay, so it's already loaded. Stop the cassette. And there's the program, and so we can run it. All right, so now we need to prove that we can save with our new cassette player as well, our cassette interface. So I'm going to do is a csave, and we'll call it primes. But what I'm going to do is put it on a totally different spot on the tape. So first thing we're going to have to do, though, is switch play and record on this, because the Altair cassette interface does not like 2 cords being plugged in at once. So I'm going to move that from playback to microphone. I'm just going to flip this tape over and use the other side of it. And I'll just zero that out. And I'll hit pause. Oops, and record play. All right, and then you also have to swap the cord in the back from tape play in to tape record out. All right, so that should all be ready to go now. So let's go ahead and we'll do the save. Oh, actually, I need to let the recorder go to record some idle leader before I hit return. We want a few seconds of leader here. All right, that should be plenty. All right, so this should be recording now. All right, that's done already. Stop the tape. I don't have this very stable, do I? Stop the tape, rewind it. And let's do a new here. So we see that's clean. All right, I'm going to go ahead and swap back to the headphone jack. And then swap in the back of the computer back to the tape in jack. All right, that looks like that's all right. All right, so now we do C load. And also you can just put in the P. In fact, you don't even need trailing quotes when you have quoted items in the commands. Basic doesn't even care. So I'll hit play over here. And let's see if it'll load the primes program we saved. Again, the first few seconds of this is just the leader that we had in there as a buffer space. And then the program load itself, once it gets to the data, goes relatively quick. All right, that's done already. And there we go. All right, so our drop-in replacement worked exactly as expected for booting with the multi-boot loader ROM. It would also have worked exactly correct for a bootstrap loader that you might have toggled in on the front panel. And once we had basic up and running, the cload and csave commands work exactly as expected. And the tape we're writing here would be interchangeable with somebody who actually had a cassette interface. All right, so that's pretty much it for this video. We've got what we wanted, and we did it with the Solid State Music IO4 board for the most part. There are other serial boards that will work, as mentioned earlier. And so I've put a link in the description below the video. Go to that link. It'll list some of those boards. Some may work, some may not. I haven't tested them all. And what I'd love to hear is any work that anybody does with this. Let me know what you come up with, and we'll update that list to include what works and doesn't work and what kind of modifications are required to make those boards work.